So, good morning, everybody. I will continue on the lecture about fertility. And I started talking about this spreadsheet in the previous class on Tuesday. The idea here is just to give an example of how to estimate all those rates that we discussed during the lecture. And for this, I'm just getting data from the US in 2012. As I mentioned, this spreadsheet you can download from the course website, right? So just under the topic of fertility in our course website, there'll be a link to example of fertility rates in Excel. You download it. It's going to be a compressed file. You uncompress it. It's going to have one file for Brazil and one for the US. Brazil is simple. It's just age-specific fertility rates for several years, as I showed in the last class. And this one here is just 1 year for the US, but then we will do several different rates. In order to calculate these rates, I had to collect some data, right? And I pretty much used data from another textbook that's mentioned here at the bottom. And the cells highlighted in yellow are the data that I had to collect. So I had to have number of women in each one of the age groups. And the age groups, the standard age groups that we use to estimate fertility rates are the 7 5-year age groups, right? Going 15 to 19, going until 45 to 49. We also need the number of births to women by age group, by the age of the mother when they had a specific child in 2012 in this case. So in this case here, out of this 10.4 million women between the ages of 15 to 19, 305,000 of them had a child back in 2012. And out of these 305,000 children from this woman, 149,000 of them were daughters, right? So in this column here, I have the number of daughters that this woman here had back in 2012. So here it includes baby boys and baby girls, here only baby girls. And this number here comes from life tables, comes from this other set of data that we usually estimate, that we usually use to estimate life expectancy. You're going to better understand this column here when we discuss the mortality chapter, the next chapter in our course. But in order to understand why I'm putting this here, you just have to think that for this exercise to estimate these numbers, what demographers did, they considered the mortality rates of this woman here by age group back in 2012. And based on the mortality rates by age groups, in other words, age-specific mortality rates, they know how many women will survive into the next age group. And life tables usually start with a number that will be the number of births, the number of people that we create in this hypothetical cohort that will experience the chances of dying. And the number of people in the life table that we usually use, that number of people that will experience the chance of dying, is this 100,000 here. So 100,000 people in this hypothetical cohort in the life table will experience chances of dying. Some of them will survive to the next age group. Some of them will not. Some of them will die. And if women had a chance of dying before age 15. But let's say that all of these 100,000 women survived to age 15. Let's say even further. Let's say that all these women survived to age 19. So all of them reach at least 20 years of age. So all these women were alive when they were 15, 16, 17, 18, and 20. So they all lived, all of them, these 5 years. So each woman, out of all of these that were born in the life table, lived these 5 years in this first age group here. So if all women lived 5 years, how many years in total would they all have lived, considering this number of people here, this number of women? We would have 500,000, right? All 100,000 women survive age 15, 16, 17, 18, 19. 100,000 times 5, 500,000. But the reality is that some of them die. Some of them die even before they reach age 15. That's why this number here is below 500,000. In this example, is 495,000. And then some women will die before reaching 20 years of age, and they will die between these ages of 20 and 24. So this number is going to be below this one. So as you go further in age, more women will die, and the number of total years that they lived will be lower than 500,000. This number of years that they all lived throughout these age groups, that's what I mentioned before, is person years, right? The number of years that people lived throughout a specific time period, right? And this time period here is 5 years, 15 to 19, right? 20 to 24, 25 to 29. This concept of person years, as I mentioned in previous classes, and I highlighted in the last class as well, is important for demographers because that's the appropriate measure to be included in the denominator of rates, the number of person years. If I'm trying to calculate the fertility rate for 2020, I need to count how many months each person was alive in 2020. So if someone was alive in January and died in November, that person will count 11 out of 12 months. If someone was alive from January to December, that person will count 12 out of 12 months, 1 year. If someone was born in July and was alive in December, that baby will account for 6 out of 12 months, 0.5 years, right? So this concept of person years is also part of this column here, which is the number of women surviving to the age interval. And the notation in the life table is this big LXN. And the number of this, the size of this hypothetical cohort experiencing the mortality rates is called the radix, the little L0, okay? The 0 there is a subscript. It's just because in Excel here, the formatting doesn't show it. It's an L with a little 0 in the bottom. That's exactly this notation that we saw in this one here. That's the big LXN, and this is the little L0. Okay, so these two numbers here that we will need to calculate the net reproduction rate and the mean length of a generation. Because of this, we are collecting this data here. So let's start from the easiest thing, from the left to the right. So the midpoint of an age group, first, I will use it later on. I will just get the beginning of the age group plus the beginning of the next age group and divide by 2. Right, so in this case here, it's 15 plus 20 divided by 2. This one here, it's 20 plus 25 divided by 2. Number of women, if I sum them all, I have 73 million. Number of children that they had in the period, if I sum them all, I have 3.9 million. The age-specific fertility rate. The age-specific fertility rate is the number of births divided by the number of women. So this B here is referring to this B. It's just a notation within the spreadsheet. The F is referring to this one here. And if you look in the lecture, that's exactly this formula here, births divided by the number of women, okay, on slide 10. So I just divide one by the other, just get this divided by this, and then I do everybody, right? And in this example here, I'm not multiplying by 1,000. In this slide here, was multiplied by 1,000. And after, when I wanted to calculate the total fertility rate, I had to divide it by 1,000 only if I had multiplied it before. But I'm not multiplying it. I'm just dividing one number by the other. And then I sum them all here, which is exactly this notation of slide 13. I add them all. And then I multiply by the width of each one of the age groups. And all the age groups have the same width, which is 5. Since all age groups have the same width, I can sum the age-specific fertility rates first and then multiply by 5, or I can multiply before and then add them all. But since they have all the same width, I add, and then I get this number and multiply by 5. So the total fertility rate in the US, using this data from 2012, was 1.88. So what does it mean? If we get a hypothetical group of women and expose them to the chances of having children based on these age-specific fertility rates, they would have on average 1.88 children per woman. That's a hypothetical measure, right? A hypothetical cohort measure. Just remember that I explained the Lexis diagram in previous lectures. You have the Lexis diagram here. Here you have time. Here you have age. For this example here, we are getting data from 2012. We are getting data about all women. We are getting them from 15 to 49 years of age. But we are saying based on this data here, from this woman, I want to know if I expose a hypothetical group of women to those rates, how many children on average they would have. When this woman here from 15 to 19, they become 20 to 24, they will not experience these rates here. They will experience rates later on, 5 years later. So this woman here, when they get 5 years older, that's not the rate of fertility that they will be exposed to. It's going to be a rate 5 years later. So that's not the real cohort exercise. That's why it's called a hypothetical cohort exercise here. So what I'm pretty much doing is kind of saying, this is a hypothetical cohort. I'm getting these rates here and putting them here. Just putting them, allocating this to the diagonal, right? And then I'm saying, let's expose this hypothetical group of women to these age-specific fertility rates throughout their reproductive lives, from 15 to 49 years of age. How many children on average they would have? Based on this data, 1.88 children. This Lexis diagram here, if you go back to the first lecture in the introduction, it's going to be there, okay? So I discussed that, and all this concept of hypothetical cohorts is going to be applied even for the mortality. Mortality is going to be the same thing. We get mortality rates for a specific year. Let's expose those people, a hypothetical cohort of people, to those mortality risks. Hypothetical cohort. How many years on average they would live? So this exercise of hypothetical cohort, we do it for all the components: fertility, mortality, and migration as well. Right? Usually we talk more about them when you're talking about fertility and mortality. So this is 1.88, the first one. Now let's get, oh, and another one, even simple one that I didn't talk here. The general fertility rate. What is the general fertility rate? The number of births divided by the female population between the ages of 15 to 49, multiplied by 1,000. Is this number here. That's the general fertility rate. I'm pretty much just getting the sum of births divided by the sum of women multiplied by 1,000. I could, if I just did it, this one here, divided by this times 1,000, I would get the same number, right? 53.6, okay? Cool. So now let's talk about reproduction. So fertility, the numerator, it's both baby boys and baby girls. The denominator is only women in fertility rates. Reproduction rates, still women, only women in the denominator. But numerator, only daughters. So let's get these ones now. And let's calculate the age-specific fertility rates only for female births, only taking into account baby girls. So what I'm going to do, I'm going to calculate column 7 here now. It's this number divided by this woman, right? So this 10.4 million women had 149,000 daughters in that period, and that gives us an age-specific fertility rate of female births of 0.0143. Okay, and if you go in the slides, it's gonna be on, we are doing this part here first, right? Is ASFR, XN, only for female births on slide 20. And then we add them all, as we do here, we add them all and multiply by the width of the age groups, always 5. So that's why I can add them all first. And then I get this multiplied by 5. So if we exposed a hypothetical group of women to these chances here of having daughters, they would have on average 0.9 daughters in the period per each woman, right? So that's the result that we are looking here. Here, we are considering children, both sons and daughters. Here, only daughters, right? Why the gross reproduction rate? So this is the gross reproduction rate, right? The one that we saw here. The gross reproduction rate is based on this concept of population replacement, with the idea that we want to know how many daughters on average women are having, to know how many daughters we will have in the next generation that will replace the generation of mothers, right? It's looking at replacement of population, replacement of generations. In this case here, if we have a number below 1, we expect that the next generation will have fewer daughters, so we expect fertility to decline overall, to have fewer births overall. But some of these women here that we calculate for each one of these age groups, they will not survive to the next age group. Some of them will die. So we have to take into account the mortality of these mothers. And that's what the net reproduction rate does. It considers the effect of mortality among mothers from the time of birth of their daughters. So mothers can die before they reach the next age group. We have to consider that. And that's that term, the term that considers the mortality of these mothers is exactly this one here. The total number of years that they live within that age group divided by the original number of women at the beginning of the period. Since we are talking about 5-year age groups, we multiply the radix by 5, the little L0 by 5. And then we get this overall number of years that they live within the age group. The big LXN is the number of person years lived within the age group. The ASFR is also still only for daughters. We also have here the width of the interval. The only difference on the formula from the NRR to GRR is that here we just had the age-specific fertility rates for daughters and the width, and here we add mortality. Okay? So let's do it. So now we have the age-specific fertility rates taken into account only daughters that we calculated the gross reproduction rate. But now we have also the information about mortality. So let's just do it step by step. Let's do this part here first. Get the big LXN and divide it by 5 times the little L0. Is this column 9? Proportion of women surviving to the midpoint of the age interval. So I just get this one here, divide by 5 times this number. So we're just saying that 99% of women, they will survive to the midpoint of this age group. 98% of women will survive until the midpoint of the age group. What's the midpoint? This is the midpoint of each one of the age groups, 22, 27, 32.5, 37.5, and so on. You see that like this number, this proportion of women surviving to the midpoint of that age group declines as the women get older because older women have higher chances of dying within this age group of 15 to 49, right? Now we have the age-specific fertility rates only considering female births from here. We have this other term here for mortality. We can multiply one by the other. So now we're going to have the number of daughters per surviving woman during the 5-year interval. How do we do this? Just multiply this by this. This multiplication here is just this portion here of the formula. This number multiplied by that, right? We do this and we add them all. When we add them all, we are just doing this exactly same exercise here. Since the width of the interval is the same, 5-year age groups per all the age groups, that's why we can add it first and then multiply later. So we add it first and then we multiply by 5 afterwards. Then we have that if we have a hypothetical group of women that experience these chances of having baby daughters and these chances here of dying throughout their reproductive ages, they would have on average 0.904 daughters. You see that this number, 0.904, is smaller than 0.917. Because that 0.917 was not taken into account mortality. It was pretty much saying that all these numbers here were equal to 1. If you just do this, just do here 1, 1, 1, 1, everybody survives. There's no mortality. See, this number becomes the same as that other number because you're not taking into account mortality. But if we do take into account mortality, then the net reproduction rate is smaller than the gross reproduction rate. Okay? So that's just implemented that formula from these slides. And then the final one here is the mean length of a generation. The mean length of a generation, we want to know what's the mean age of mothers giving birth to live daughters, right? To daughters born alive, considering the age-specific fertility rates that we have right now of having daughters and the mortality that those mothers are exposed to. So this part here is the same as the net reproduction rate, but now we multiply by the midpoint of the age group with the assumption that fertility happens with the same level within each age group and divide by the net reproduction rate. So now here, that's what we have on column 11 here. We get the age-specific fertility rate, multiplied by the mortality, multiplied by the width of the interval, which is 5, and multiply by the midpoint of the age group. Again, when we multiply by the midpoint of the age group, our assumption is that this chance here of having baby daughters and this chance here of dying happens in the same level between the ages of 15 and 19. So we get the mid of that period, okay? The mid of that age group. So if we're just multiplying columns 2 and 10, right? We just get the midpoint here by this part. So we have ASFR times this, times the mortality factor, times the midpoint. So what we are doing is just getting this number here, multiplying by this. That's what we have here, column 2 times column 10. But also we already include the width of the interval. So we have the age-specific fertility rates considering only the female births, times the mortality factor, which is K9, times 5, times the midpoint of the interval, right? It was already grouped, so I just used the grouped ones. I multiply them all. So what I'm doing here is just calculating so far just the numerator of this formula, okay? Just calculating the numerator of this formula. I add them all. When I add them all, now I have the full numerator of the formula. Now I have to divide this 25 by the NRR. So I get 25 divided by 0.904. So women are on average 28.6 years old when they have daughters, according to this data here that consider both the chances of having daughters and also the mortality factors. Cool? So that's just a really clear example, but you have to have these 4 sets of information here: number of women, overall births, births of daughters, and then the mortality factor as well to calculate everything. And this curve here, I just show it from the first one that we estimated, the age-specific fertility rate, just to show that those graphs that we see of age-specific fertility rates, they can be easily generated from an Excel spreadsheet, right, after you make these calculations. Cool? Any questions? So we have the total fertility rate, the gross reproduction rate that takes into account only daughters. Here we take into account daughters and mortality. And then here also only daughters and mortality, just to know what's the average age that women are having their daughters. It's just to compare over time. So maybe if we see a woman delaying the age in which they have children, and we have data for several years for the US, we would expect this number here to increase because women are investing in their education, are investing in their career, so they postpone the age in which they have children, and of course, in which they have daughters, their mean length of a generation would increase. So these different terms here mean the same thing. The mean length of a generation means that it's the mean age of mothers giving birth to daughters born alive. Okay? All cool? Great. So far in the fertility chapter, we only estimated a series of fertility and reproduction rates. So we just estimated a bunch of different indicators to understand fertility and reproduction that we can use it for different countries and different populations. But what are the causes of fertility declining or increasing over time in specific populations? So so far we just looked at this in the previous slides. The reasons of why fertility increases or declines is related to the theories of fertility that we talked before, right? So we now start to have in society some changes. Instead of living in agricultural areas in which having a lot of children is good because they can serve as labor, now I'm living in a city which is more expensive to have a child because I have to provide housing, I have to provide food is more expensive, housing is more expensive, I have to provide education, education is expensive, and so having children becomes more expensive. So the flow of wealth is not from the children to the parents anymore, it's from the parents to the children. And we start to increase female labor force participation, there are changes in society, and then you start to see a decline in fertility. And also related to the major demographic transition, right? Now people realize that they don't have to have as many children as before because mortality is declining a lot. So you don't have to have as many children for them to survive into adult ages. So you can just have fewer children so they survive to adult ages, right? So there are a series of different factors, indirect determinants of fertility. All these general socioeconomic, cultural, attitudinal, family planning, environmental variables that explain indirectly why fertility changes over time. Urbanization, people getting more educated and wealthier, that actually people tend to have fewer children because, again, they know that their children will survive to older ages and because it's expensive to have children and to give them a good life standard. If I have a war, if I have natural disasters, all that will affect the chances of having children, right? But these general factors, overall contextual factors of why people might affect the decision to have fewer children are too general, and they affect fertility in a more indirect way. So what a series of demographers try to do is to understand what are the factors that actually closely explain why women have fewer or more children over time. And these factors that closely explain why women having fewer children over time are influenced by the indirect determinants of fertility. But what a series of demographers did, and this diagram here is from like these studies by Bongos, John Bongos, one of the main demographers dealing with like fertility issues, is, so we're trying to understand what are these general factors that affect these proximate determinants of fertility, and then these factors here will affect fertility itself. So what are those proximate determinants of fertility? They actually were first introduced by Davis and Blake back in 1955, and the term that they used was intermediate variables. So the means for regulating fertility have been popularly labeled the intermediate variables, was labeled back by these researchers. So they kind of like elaborated based on empirical studies. They come up with 11 variables through which any social factor would influence the level of fertility. So they found 11 variables here that it would influence fertility, and these 11 variables are influenced by these indirect determinants of fertility. Because, see, if I move to an urban area, move to an urban area, it's going to be more expensive to have children. But how in practice will I not have children? Usually people will continue to have sex, but if they don't want to have so many children, contraception. Other people, oh, I'm experiencing economic issues, I'm unemployed. Some of these people will delay the age in which they get married. So unemployment could affect the age in which people get married. So the age in which people get married is here, the proportion of people getting married is here, influenced by unemployment, this general indirect factor. Urbanization, I'm going to have fewer children because it's more expensive. I'm going to use contraceptives. Contraceptives is here. And then the proportion of people getting married and contraceptives are here, and then they influence fertility. And they are some of the 11 variables here discussed by Davis and Blake as these intermediate variables. And they kind of group these 11 variables in 3 groups: intercourse, conception, and gestation. And then afterwards, some decades later, Bongos, in his studies from 78 and 82, he kind of like based more on empirical studies. He realized that out of all these 11 variables, 4 of those accounted for most of the differences in fertility across populations. Why he was trying to simplify it from 11 to 4? Because when you have more simple models like that, explaining the most as you can, you gain in terms of having data accessible from all these different countries. And because like some of these more developing or less developed countries, would be really hard to find all these 11 variables. But maybe it would be more feasible to find these 4 variables, and I can compare them with other countries as well. So the idea is to explain the most with fewer amount of data, right? And of course, the importance of each one of these 4 variables across time and populations and space, okay? The 11 variables that were discussed by Davis and Blake are the ones listed here. So they are grouped under intercourse variables, conception variables, and gestation variables. Age of entry in sexual unions, proportion of women entering sexual unions, amount of reproductive period spent after or between unions, and then some variables related to exposure to intercourse, voluntary abstinence, involuntary abstinence, and sex frequency. The conception, fecundity or infecundity, use or non-use of contraception, and fecundity or infecundity as affected by voluntary causes. Here it's involuntary causes, here voluntary causes. And then gestation related to miscarriage and abortion. So we have these 11 variables. And what Bongos realized is that these variables here, these 4, age of entry into sexual relations, fecundity or infecundity affected by involuntary causes, use of contraception, and abortion accounted for most of the differences across population. So there is this term, parsimonious. He was trying to be parsimonious, explain the most of fertility with fewer variables, right? So the intermediate variables proposed by Davis and Blake their behavioral and biological variables directly affect infertility. And all those indirect factors, other social, economic, cultural, and environmental factors influence fertility, operating through the intermediate variables, as we saw in the diagram. So this is just a summary of the table that I just showed. They had a total of 11 intermediate variables subdivided in these three groups: intercourse, conception, gestation. Proportion of persons who marry, length of time married, frequency of sexual intercourse, contraception, voluntary or involuntary infecundability, and likelihood of miscarriage or abortion. Okay? Then Bongos operationalized the Proximate determinants of fertility to incorporate them in a more quantitative approach, in an approach that would be simpler, more parsimonious, so people could apply it to different countries and different years. It was designed to facilitate quantitative specification of variables, and it's one of the most useful frameworks to understand fertility, right? And he cites the 7 proximate determinants of fertility that they are the most important to explain variation in fertility over across populations: marriage and marital disruption, contraceptive use and effectiveness of the contraceptives, prevalence of induced abortion, duration of postpartum fecundability, waiting time to conception, risk of intrauterine mortality, and onset of permanent sterility. And he realized that out of these 7 here, the first four of them were the most important. Proportion of women who are married, because that limits the exposure to intercourse. Younger women have less sexual intercourse, household with both mother and father. There is a closer surveillance on their children. Mother, well educated, there is a more awareness of cause of pregnancy. So if their children, boys and girls, are having sexual relations, there is more discussion about use of contraceptives. And later age at marriage, as people get married at later ages, that we will affect fertility as well. We will have lower levels of fertility, right? So proportion getting married. And in this case here, it's not just about contraception, which is the second point. When you have more mothers who are more well-educated, they will teach their daughters that it's best to invest in their education and career first, get married later, and then that will affect their fertility by getting married later, right? Use of contraceptions, induced abortion, and involuntary infecundability. So those societies that have, that women breastfeed for longer periods, that will prolong postpartum amenorrhea and will suppress ovulation, so that will affect fertility. Longer women breastfeed, the chances of having children will decline even longer, okay? So that's the idea here in the same diagram, kind of trying to summarize those points that Bongos emphasize of being the main factors directly affecting fertility, which he calls the proximate determinants of fertility. You have a series of indirect determinants of fertility: socioeconomic, cultural, attitudinal, family planning, environment. They affect proportion of women getting married, use of contraception, abortion, and postpartum infecundability, the 4 main ones. But then also other 3 variables that account also for some variation: frequency of sexual relations, intrauterine mortality, and sterility, okay? So that's the overall framework from Bongos that's always interesting to analyze, because that affects fertility. So when we estimate the proportion of people getting married or divorced in a specific country over time, That's because we are trying to understand these proximate determinants of fertility, factors that closely influence the levels of fertility in one country. And then he created some indices for the first 4 approximate determinants of fertility in order to be easier to compare variations across countries. So pretty much these indices, they range from 0 to 1, 0 being the greatest inhibiting effect on fertility, and 1, no inhibiting effect. So the marriage pattern index, you pretty much just get the proportion of married women, right? Percentages in percentage terms goes from 0 to 100. Proportion goes from 0 to 1. In this case, 1, when all women are married, and 0, when none of them are married. So 1, when all women are married, that is in this index, that's the highest number that you can get of no inhibiting effect on fertility. By being married, they are more exposed to have children. They are more likely, they have higher chance of having children. And then 0, when none of them are married, that's the greatest inhibiting effect on fertility. Oh, but I know a lot of people who have children and they are not married, but they still are less likely to have children than the ones who are married. Contraception index. 1, when no contraception is used. If no contraception is used, there is no inhibiting effect on fertility. And 0, when all women are using effective contraceptives, the greatest inhibiting effect on fertility. Abortion, 1, when there is no induced abortion, and 0, when every pregnancy is aborted, right? So always 0, the greatest inhibiting effect on fertility. Postpartum fecundability, when no women are in the postpartum infecundability period, and 0, when all women are. And then Stover, and also like other demographers, are coming up with just trying to improve these variables discussed by Bongos because of changes that our society experiences. So Stover's modifications and extensions to Bongos' model consider demographic realities in modern societies, right? Instead of using, I just mentioned to you, you could criticize this marriage pattern index by saying, oh, actually, women are having children without being formally married. So what he suggests is use of sexual activity instead of marriage as the indicator of exposure to pregnancy, right? Extension of the sterility index to measure infecundability from all causes, not only from postpartum infecundability. Revision of the contraceptive index to consider the fact that uses of sterilization could become infecund before the age of 49. If we use condoms or pills, it's a temporary use of the contraceptive. But if men or women get sterilized, that's a permanent method of contraception. So those people, they can become infecund permanently voluntarily before the age of 49, right? So distinctions between the use of contraception are important if you have temporary or permanent contraceptions being used. And that will change the estimate of total fecundity, right? So the idea here, instead of having this marriage pattern index, is to have the sexual activity index. In the sterility index, measure infecundability from all causes, not just from postpartum, and contraception kind of realize that countries that have a really high proportion of men or women mostly getting sterilization, that they will not have children from the time that they decide to get sterilized until the end of the childbearing years, okay, until the end of their lives, of course. But here we are talking between 15 and 49 years of age. So the idea is that we try to summarize the model, come up with the first four here that kind of like explains most of the variation in fertility, but society changes. So we will always go back to this framework and try to change it and to improve it to the reality of our contemporary societies, okay? So now I discussed ways to estimate fertility indicators, fertility rates, reproduction rates, discussed these frameworks to analyze what are the factors that influence fertility. And now I will talk about, give some examples of fertility levels and trends in the world and specifically in the US as well, right? So that's what most of this lecture is going to be about from now on. So discussing world fertility trends and patterns. A country is classified as having high fertility those that have total fertility rates higher than 3.2 children per woman. And that's the case of mostly of sub-Saharan African countries, right? We expect that these countries will experience declines, gradual declines in fertility in the next decades, but they still have a high number of children per woman, but this number on average being 3.2 children per woman. Low fertility countries are those with fertility below the replacement level. So fertility below 2.0, 2.1 children per woman. And that's the case of European, Asian, Latin American, and Caribbean countries. Also, we see some slight increases in the, we expect to have slight increases in the lowest low fertility rates in the next 2 decades. So in this case here, let's just read this last sentence. Some of the previous decline was a result of postponement of fertility. What has been happening in some countries is that women are not deciding to have fewer children overall by the end of their reproductive ages. What is happening is that they're postponing the age in which they have children. When they postpone it, you have this immediate effect, short-term effect of decline in fertility, the period effect. But when they decide to actually have children later in their ages, fertility might come up. So what we might see as a negative effect at the beginning, it might disappear, or at least a little bit of it might come up in the next decades, showing that the effect was more related to a tempo effect, to a postponement in fertility. So the idea is that we might be experiencing some declines in fertility in some countries. Maybe they were like around 2, 2.1. Let's say here we have a TFR, and this is time. We had a TFR, let's say the replacement level 2.1, and then it starts to decline. And this decline here, we have been seeing in a lot of European countries, Eastern European countries, Asian countries. And then so a lot of demographers and governments start to get concerned about this, because if we don't have enough children, the future generations will have a much higher proportion of older people, and then it will be hard to produce goods and food and resources to everybody. But what some demographers start to realize is that this decline that we have been seeing in some countries is just a short period decline, a short-term decline. Because some of the women instead of having children in their 20s, they're postponing to have their children in their 30s, right? If that is true, if you keep going further in time, and then this woman, when they have their daughters, and let's say that their daughters also decide to have children around their 30s, at some point, you might see a rebound of fertility going up again. But the question is, how much it will increase? Will it reach the level that we had before, or will be below it? All right, so now, when we start to see these really small increases and decreases in fertility, demographers start to talk about decimal points in terms of total fertility rate. Is it going to be 1.85, 1.93, 2.05, and so on? But with the idea, always concerned with the replacement level. And the replacement level of 2.1 is the overall, the world average. More developed countries that have lower sex ratios at birth, so not so many more boys being born than girls, and mortality is low, so the girls will reach reproductive ages, then in that case, the replacement level is below 2.1, because we don't have so many daughters, we don't need so many daughters to reach their reproductive ages in order to replace their mothers, okay? But we are always concerned with replacement level. Replacement level will affect the composition of the population. The composition of the population will affect the economy, will affect production, will affect occupation, and so on, right? How much will? We will go back all the way? We will stay below? It will go higher? That's the question, okay? So this discussion about period effect and tempo effect is to know if the effect is just related to the short term, the period effect, or like the tempo that people postpone in which they have children, and then afterwards, it will bounce back, right? So that's one major question that demographers have nowadays in relation to understand these variations, these slight variations in fertility. I'm not saying that fertility will go back to 3, 4 children per woman, but this previous decline, this period effect, might be just related to postponement in fertility, and then we could expect it to go back. But we see some countries with really low levels of fertility, like South Korea, for example, because it's so expensive to raise children there that fertility is not bouncing back. So overall, the families are seeing the desired number of children of 1. 1 is enough, right? On average. So it's just interesting to see that now we are talking about really minimal changes in order to understand how the population is going to be in the next decades. Within this group of countries that have really low levels of fertility, Pilar and Kohler, they kind of like subdivide them in these other subgroups here. Countries that have low fertility are the ones with total fertility rates between 2.1 and 1.6. There were around 43 countries back in 2013. Very low fertility countries are those with total fertility rates between 1.5 and 1.3. And the lowest low fertility countries are those with total fertility rates under 1.3 children per woman. 9 countries in 2013. You see South Korea is there. Taiwan, Poland, Portugal, Singapore, Hong Kong, and Macau. Okay? So we start to look at the decimals because those little changes here might affect the composition of the population in the next decades. Affect the composition, we will affect what kind of services the population will need. We need more services for the older population, fewer schools, and how it's going to be the technological advancement. We will need technological advancement for the fewer proportion of people in working ages to produce enough resources to this increasing older population, okay? Depopulation is the decline in population size. It is projected to happen in most countries in the next 50 to 100 years. And it's based on the rate of natural increase, the RNI. You pretty much get the crude birth rate, subtract by the crude death rate and divide by 10. Remember that the crude birth rate, you got the number of births divided by the population in a specific year. Crude death rates, the number of deaths, and divided by the number of population in a specific year in a specific country, for example. And both of them you multiply by 1,000. When you subtract one by the other, they're still by 1,000. If you divide it by 10, then now the rate of natural increase is reported in percentage terms, right? So the rate of natural increase is not reported in thousands as the crude birth rate and death rate, it's reported in percentage terms. So already in Europe as a whole, there was observed no population growth in 2014. So a rate of natural increase of 0%. The other countries, other examples of countries with zero or negative rate of natural increase. You see here a lot of them, Eastern European countries, but also Germany and Italy, Bulgaria, Serbia, minus 0.5%, Latvia, Lithuania, Hungary, Ukraine, minus 0.4%, Germany, Italy also negative, and Russia, 0. And depopulation in Russia is expected from 143 million, based on data from 2014, to 134 million in 2050. I mean, and with the war going on now, with like all these refugees going out from Ukraine to other countries nearby, Slovakia and Poland and Hungary and so on, that will affect the population size during the war, right? And some of these people might decide to not go back. And also, depending on how long the war will last. But even without the war, the overall level of fertility compared to mortality was also already really low in Ukraine. And now with like this country being devastated, cities being destroyed, what's going to be? People who were planning to raise a family, a lot of them will postpone having children because of this harsh situation that you're living in, right? So all that reality that they're experiencing now will affect fertility, of course, is affecting mortality, is affecting migration, and then it will affect how the population is going to be in the next decades, the next centuries, right? And Russia as well. I mean, you start to see a lot of like articles discussing the fact that there have been much more losses of Russian army that the Russian government expected. So if that's true, and if it continues to happen, those are usually young people and usually young men in reproductive ages. So that might affect even more mortality or fertility in Russia. And because of all the sanctions that Russia is getting from Western countries, we already see in Russia population having also a lack of basic food and resources. When people are in those hard situations, that will also affect their decisions to get married and to have children. So the whole region is going to be messed up by what's going on right now. And it's not just a matter of like, oh, the war finishes tomorrow is going to go back to how it was. No. The psychology, the desires of people will change, and will change it for the next decades, right? And that will affect all these demographic indicators related to fertility, to mortality, and to migration, right? So, I mean, of course, now, I mean, whenever there is a war, the information, it's so hard to know what's true, what's not. It's good to get information from different sources and everything. And you see articles going different ways. It's going to be good. It's good to try to understand and think of how it's going to be in the future. But at the same time, we're going to have a clear idea of how the war will affect everything, fertility, mortality, migration, in the next years, when we start to see more information, more clear information about what's going on, and more data is collected and so on, right? But it will affect, it is affecting. The UNHCR, the United Nations Agency dealing with refugees, already showing more than 3 million, almost 4 million refugees from Ukraine going to surrounding countries. So that's already affecting. These numbers are real, right? And of course, mortality too, and fertility. We talked about replacement level fertility. Total fertility rates at or near replacement are those of 2.1 children per woman. And the idea is that we need, on average, 2.1 children per woman in a society, so the next generations will replace the previous generations of mothers and fathers. Based on data from 2013, 79 countries had TFRs at 2.1 or lower than 2.1. So they were exactly either at the replacement level or below the replacement level. And just remember this 2.1, just to highlight it again. Why not only 2? Because we know that more boys are born than girls. The biological sex ratio at birth, if there is no cultural effect influencing that, is usually 105 boys being born for every 100 girls. If some countries, there is a preference for sons, then the sex ratio at birth can increase much higher than 105. It can reach 120, for example, right? But let's say that we are around 105. So we have to have a little bit higher fertility in order to have enough daughters to replace their mothers. And another thing, some of these daughters will not reach 15 years of age, will not reach 49 years of age. We saw when we calculated the net reproduction rate with that information about mortality. That's not 100% of the women will reach all those age groups. The proportion is always below 1 because of mortality. But in more developed countries in which mortality is lower and there is not a son preference, the replacement level for fertility would be a little below 2.1, still above 2, but below 2.1, something between 2 and 2.1. Because mortality being so low, a greater proportion of these daughters will reach reproductive ages. And also because there is no preference for boys in relation to girls, you don't need as many more girls, right? So this 2.1 is not always the same. It's a world average, let's say. Some countries with low TFRs do not experience depopulation. There are still large numbers of women in childbearing years due to past high fertility. So some countries that have in the short term declines in fertility, they still don't see a rate of natural increase being negative. Because since in previous generations there was so much fertility, and these previous children reach reproductive ages, now you have a lot of women reproductive ages that overall might be having been exposed to a low TFR, but they are still in big numbers. So you don't see so much depopulation, right? And another thing too is the effect of migration, right? So if some countries receive a lot of immigrants, that also affects the size of the population. African countries have the lower rates of fertility in African countries. And African countries still have high levels of fertility, right? As we saw in the previous slide here. We mentioned here that, for example, sub-Saharan African countries are the ones having really high levels of fertility, around 3.2 children per woman. But in more recent years, we have been seeing declines in the fertility of African countries. And we also have been estimating lower levels of mortality. So we have seen improving mortality, which means declining mortality, and fertility declining as well. And also lower rates of immigration in some of these countries. So this trend will be responsible for depopulation, even in some African countries, in the next 50 years or so. So remember the lecture of Hans Rosling, when he was projecting the African population to increase from 1 billion to 2 billion in 2050, and then 4 billion in 2100. But as we progress in time, African countries will also experience improvements in mortality and declines in fertility, which will stabilize the overall size of the population. So that's why we don't expect it to increase much more than the 4 billion after 2100, because they will also experience those, right? Declines in fertility and improvements in mortality. What are some of the implications of low fertility? When we have really steep declines in fertility, the birth cohorts become smaller. That means that we have smaller proportion of children in the population, right? With smaller proportion of children in the population and increases in life expectancy, people getting older, you start to have a population aging. We're going to have higher proportion of people in older ages. Fertility decline, lower proportion of children in the population, people getting older, so the proportion of people in older ages will increase. Larger proportion of the population that older than 65 will increase in all these countries. And we're going to have smaller proportion in working ages. So all that will affect how our society will have to organize. Like I said, we might need fewer investment in education. On the other hand, we might need more higher level education at the college level to give really good skills to the whole working age population to be more productive, because now we have to support a larger proportion of people in older ages. Between 2005 and 2050, the United Nations expect that the old age dependency ratio will double in developed countries from 22 to 44%. How is the old age dependency ratio calculated? We get the number of people with at least 65 years of age divided by those between 15 and 64, multiplied by 100. So it's expected to increase from 22 to 44%. Healthcare and pension programs not well equipped to handle large increases of elderly population might bring some problems to these countries, because these countries are not equipped to have such a large proportion of population that will need specific healthcare facilities. And that will be a pressure on the governments, right? So the next chapter, I will have to start being a little because we missed that class because of that storm some weeks ago. The next topics here, we're going to discuss fertility changes in the US with a focusing on adolescent fertility, non-marital fertility, and childlessness, and finishing with male fertility, which is still an understudy topic in demography, but of increasing importance. And then after that, we go to the next chapter on mortality. Okay, so have a great weekend, and I see you guys on Tuesday. Thank you.